Hello, this is Scholar Strife doing some geometry. We're gonna find angle measures in polygons. So let's start off with some vocabulary. A diagonal. So let's say we have. Oh, I always forget. Let's say we have. One, two, three, four, five. So let's say we have a pentagon. A, B, C, D, E. A diagonal is any segment that connects two vertices or two non-consecutive vertices of a polygon. So BD, the segment, would be a diagonal. And then so would this red line here, EC, or this green line, BE, or this line, AC. So anything that any two non-consecutive or non-next to, non-adjacent vertices, corners. So the polygon interior angles theorem, basically it's a formula. So the formula, n minus 2, so let's have that pentagon again. Okay, 1, 2, 3, 4, 5. n minus 2 times 180 equals the sum of the interior angles of a polygon. So n being the number of sides, n is 5. So the sum, if we added all the angles, the interior angles in the triangle or in the pentagon here, would be equal to 5 minus 2 times 180, which in this case is 540 degrees. So the total angle measurement, if you add up all the interior angles in a pentagon, is 540. And corollary, a quadrilateral corollary. Remember, corollary means basically it's like because of the previous theorem, it's automatically assumed that a quadrilateral, the sum of interior angles of a quadrilateral, is 360. Because a quadrilateral is 4 sides, so n equals 4. So 2, or n minus 2 times 180, which is 2 times 180, which is 360. And exterior angle is the angle shown here. So if you extend one of the sides of your polygon, C, D, let's call this F, the exterior angle would be this red one right here. It's on the outside of the object. So I would say angle C, D, F is an exterior angle. Okay, let's draw that picture one more time. One more pentagon. So that's an oddly shaped pentagon, but it'll work. So I'm going to extend all the sides and I'll just make them a different color. Just extending the sides. let's call this angle 1, angle 2, angle 3, angle 4, and angle 5. All these angles are exterior angles. The sum of all the exterior angles, angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5, is always equal to 360. Because all you're doing is going around in a circle. Alright, let's do some examples, or more examples. Find the sum of interior angles of any hexagon. So the hexagon has 1, 2, 3, 4, 5, 6 sides. So n equals 6. So the sum of all the interior angles is, so let's remember our formula, n minus 2 times quantity, or n minus 2 times 180. So this is going to equal to 6 minus 2 times 180, which is 4 times 180, which is 720 degrees. So for any six-sided object, any six-sided hexagon, well, there's only six-sided hexagons. That's why they're called hexagons. They're six-sided. So for any six-sided polygon, if you add up all the interior angles, it'll be 720 degrees. Example 2. The sum of measures of an interior angle of a polygon is 1260. Classify the polygon by the number of sides. Okay, so this time they give us the sum. So if I plug in the formula, n minus 2 times 180, we know that is equal to 1260. So how do we find out the number of sides? So since n minus 2 is being multiplied by 180, I'm going to divide both sides by 180. And I'm going to get n minus 2 equals n minus 2 equals, let's use our calculator here, 1260 divided by 180, that's 7. Okay, and then to get n alone, we add 2 to both sides. So n is 9. Number of sides is 9. And if we don't remember it, that is an octagon. Oh, sorry, nonagon. Nonagon. An octagon is 8. A nonagon is 9. So an octagon is 8 sides. A nonagon is 9 sides. So let's go ahead and redo that list. So we have 3-sided objects, which are called triangles. 4-sided objects are called quadrilateral. 5-sided pentagon. 6-sided hexagon. 7-sided, you can call it septa or heptagon. 8-sided is your octagon. 9-sided is your nonagon. 10-sided is your decagon. And we're gonna stick with that for now. So let's move on. Example 3, find the value of x. So this is, so in order to find x, we need to know the total, or the sum of all the interior angles. So if we added all these up, they should equal a specific number. So let's figure that out. So we have 1, 2, 3, 4 sides. So I can use my formula to figure out what the sum is. So all these angles should add up to 360. And this is for any four-sided polygon. So the total is 360. So what I'm going to do is I'm going to add all of them up. 135 plus 112 plus 71. And that's going to give me 318. And we know that x plus 318 is equal to 360. So we just subtract from 360. And we get 42 degrees. Okay, checkpoint 1. Find the sum of interior angles. Let's see here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a decagon. So my end is 10. So 10 minus 2 times 180. That'll be 8 times 180, which is 1440. Okay, checkpoint 2. The sum of the interior angles of a polygon is 1620. Classify the polygon by the number of sides. So n minus 2 times 180, that's equal to 1620. We're going to divide both sides by 180 to get n minus 2 is 9, so n equals 11. And an 11-sided object is... I don't expect you to remember this one. So if you want to say 11-sided polygon, that's fine. This is an undecagon or a unidecagon. Alright, checkpoint 3. Find angle K and angle L. So they're telling you about these markings here, in angle K and angle L, that they are the same. So I'm going to call them X and X. So X plus 68 plus 105 plus 109 is equal to the total sum. So let's figure out what the total sum is. So there's 1, 2, 3, 4, 5 sides. So we got a pentagon. So 5 minus 2 times 180 is 3 times 180, which is 540. So that's my total. So I'll get 2x plus, add those guys up, and we'll get 282 equals 540. Subtract both sides by 282, and we'll get 2x equals 540 minus 282, which is 258. And then we divide both sides by 2, and we'll get x equals 129. Okay, example 3. So these are all exterior angles, and we have this rule that says if we add all the exterior angles, so x plus 89 plus 2x plus 85, that is equal to 360 degrees. So I'm going to get 3x plus 89 plus 85 is 174 equals 360. Subtract both sides by 174, and we'll get 3x equals 186. So x equals 62 degrees. the base of a lamp is in the shape of a regular 15-gon. So they want to find the measure of each interior angle. So first we're going to find the total. 15 sides minus 2 times 180. So 13 times 180 is equal to 2,340. This is the total. So because it's a regular, that means all the interior angles are the same. So I'm going to take that 2,340 and divide it by 15, because there's 15 angles. And that'll give me 156 degrees for each angle there. And then find the measure of each exterior angle. So we already know that the total of all the exterior angles is 360 degrees. And we're going to take that and divide that by 15, because there's only 15 exterior angles as well. So that we'll get 24 degrees. Let's do another one. Find the measure of each interior angle and exterior angle of a regular nonagon. Nonagon is 9-sided. So if I want to find the total of all the interior angles, I'll take 9 minus 2 times 180, which is 7 times 180, which is 1260. Take that 1260 and divide it by how many angles there are. There's 9 of them. And that'll give us 140 degrees for each interior. For the exterior, they add up to 360. And divide that by 9 angles. And you'll get 40 degrees for the exterior. Hopefully this helped you out. Have a good day.